Side, questions 5, 6, and 7 are all directly related. All right, so you could actually do this pretty quickly if you understand how they're all related. Well, let's first look at the easy one, which is this exponential decay function. Yay? It's an exponential decay function. And on any graph, whether it's a radical, square root function, you could identify h and k and then ignore h and k and work on an xy table on your parent graph. So on this guy, let's identify the h value being 3 and the k value being -5. Okay, that means that you're going to go 3 in the positive direction and 5 in the negative direction. All right, so once you've identified h and k, I like to box in what's left over, ignoring h and k. All right, so if we ignore h and k, we could look at that exponential decay function and make an xy table for it and plug in consecutive integer inputs. So consecutive integer inputs, -3, -2, -1, 0, 1, 2, 3. What I want to do now is plug in the easiest input, 0. If I plug it in right there, anything to the power of 0 is 1. So that's my output for my input 0. Now from that point, I know that this is a decay function, so I'm going to take the output 1 and make it decay by 1/3. Now what do I mean by make it decay by 1/3? I want to take that 1 and I'm going to actually multiply it by 1/3, and that'll give me 1/3. And then I want to take that 1/3 and make it decay by 1/3 again. That means multiply it by 1/3 again. That'll be 1/9. And then decay it by 1/3 again. 1/9 times 1/3 is 1/27. And we get the picture that this is getting closer and closer to 0. It's getting closer and closer to nothing. So it's going to infinitely approach nothing, but never actually get to nothing. It'll infinitely approach nothing. So as we go down, multiply by 1/3, multiply by 1/3, multiply by 1/3, it's getting decayed by 1/3. Going backwards, it would grow by the opposite of decaying by 1/3, which is really dividing by 1/3, which is really multiplying by 3. So 1/27 times 3 is 3/27, which reduces down to 1/9. Times 3 is 3/9, which reduces down to 1/3. Times 3 is 3/3, which reduces down to 1. Times 3 is 3. Times 3 is 9. And times 3 would be 27, which is already off the graph we don't need. So let's graph these coordinates right here. 0, 1 is right here. And the coordinate -1, 3 is right there. And coordinate -2, 9 is right there. The coordinate 1 and 1/3, 1 on the x, 1/3 on the y. Let me zoom in. So my origin is here. If I go 1 on the x and 1/3, that's not even halfway up. So I put my dot right here. 1 on the x, 1/3 on the y. Not even halfway. And then the next one's 2 on the x, 1/9 on the y. That's super close to nothing. And the next one's 3 on the x, 1/27. That's really close to nothing. At this point, I can't even draw it accurately enough to show the difference between 1/9 and 1/27. So what I do know is on the x-axis, it infinitely approaches 0, but it never actually touches 0. I'm going to draw it like if it is touching, but we should know that it never actually really touches. And I might as well draw the other part of this thing. Even though we have a h and k shift, I'm still drawing it. Whoops. I want to put some x's on it later. But what I need to do is shift according to my h and k. So I need to take these coordinates and move them all 3 to the right and 5 down. So if I take this top one and go 3 to the right, 1, 2, 3, 5 down, 1, 2, 3, 4, 5, it'll be right there. And the next one, 3 to the right, 1, 2, 3, 5 down, 1, 2, 3, 4, 5, right there. Okay, now I'm honestly getting a little confused with all these red dots. So what I like to do to help me out visually is to do the K shift with my asymptote. I know it's infinitely approaching the x-axis here, but I know I need to move it 5 down. So if I move this asymptote 1, 2, 3, 4, 5 down, it'll help me out to visually see my shift of 5 down, okay? So again, 3 to the right and 5 down. Let me see right here. So we already did this one. 1, 2, 3 to the right. 1, 2, 3, 4, 5 down right there. Did I get that right, or did I mess that up? I messed it up. Let's see. One more time. 3 to the right. 1, 2, 3, 5 down. 1, 2, 3, 4, 5. Right there, yeah. Okay. And then we know that the next one is closer to that asymptote, but it's 1/3 of the way up, and then 1/9 of the way up, and then 1/27, so it looks like it's touching. So my real final graph is this guy right here. And you know what? I kind of messed up on this drawing because it should not look like it goes straight up, and it looks like I drew it straight up. It probably should be more like this. Because it doesn't actually go straight up. It always goes to the left forever. So what I would do if I were you, if you did draw the original, I would put some X's on it to show that that's not the line, or down here, right? This is not the asymptote. The real one's this red one that we drew. Your final one that does include H and K. Okay, so let's talk domain and range of that guy. The domain, your X values. Does it go to the left and to the right forever? It's obvious that this red line does go, a red curve does go to the right forever. How about to the left? Does it go to the left forever? Yes, it does. Even though it looks like it's going straight up, it never actually goes straight up. It continues to grow to the left. So X really does equal all real numbers in this case. All right? The range are your Y values, and your Y values are going up or down. Where's this graph at? Is it up above a certain value or below a certain value? It's above a certain value. What's that certain value? Yeah, y equals -5 is this line right here. Wow, that's ugly. But you know what I mean. So the graph is above -5, so you're going to say that your range is greater than -5. You can't even say or equal to because it never actually touches, it just infinitely approaches. So I probably shouldn't have drawn this line, sorry. Just wanted to show you that that's the value -5. Anyway, that's how you graph it, that's your domain and range. Okay, so we know how to do that. Let's look at this log base 1/3 of x function. Now, if I asked you to find the inverse of log base 1/3 of x, what would you do? You would switch x and y, log base 1/3 of y, and then you'd have to solve for y, which means you have to get y by itself. You don't want it in the logarithm, you have to get rid of the logarithm, and to undo a logarithm you have to raise both sides of the equation to be powers of the base of your logarithm. So you would actually make the left side the power x of the base 1/3, and you would make the right side the power log base 1/3 of y to be the power of base 1/3 also. The equal sign would come down, and you put the equal sign between the bases 1/3, and then you would say 1/3 to the log base 1/3, that cancels out. The y comes straight down, your equal sign comes down, and you have 1/3 to the x power as your inverse function, right? That takes a long time. What you could do as a shortcut is look at your logarithmic function, y equals log base 1/3 of x, and you could just cover up the log, and ladies and gentlemen, that looks like your inverse. You have it instantly. It's a shortcut. What's your inverse? Y equals base 1/3 to the x power. This is the base on the logarithm. It's going to be the base on your exponent situation. Okay? So, if you know that, if you know that your logarithmic function y equals log base 1/3 of x, the inverse of it is really y equals 1/3 to the x power, ignoring the log, then you'll be able to easily come up with the coordinates of that, right? And as a matter of fact, you already found the coordinates of y equals base 1/3 to the x. You found that over here. You did that right here. by ignoring h and k. So you found those coordinates already. So you have those coordinates right here. You agree? So we actually have the coordinates of this, which is really the inverse, the inverse of this. So if you actually have the coordinates, let me actually rewrite them right here. I'm simply going to cut them from, not cut them, but copy them from this XY table, and I'm going to rewrite them over here on this one. So all I've done is copied the XY coordinates from this one because we already did all this work. We already did all this work to find the XY coordinates of y equals base 1/3 to the x. I just copied them over right here. So now I know the coordinates, we already had them, of y equals base 1/3 to the x. And what we really want, we don't really want these coordinates. We really want the coordinates of the logarithmic function. Now, the logarithmic function coordinates, since we know that this is the inverse of this, then the inverse coordinates of these guys are simply going to be switching x and y. Switching x and y, and you'll have the actual coordinates to your logarithmic function. So instead of negative 3, 27, you're going to have 27 and negative 3. Instead of negative 2 and 9, you're going to have 9, negative 2. Instead of negative 1 and 3, 3 and negative 1. Instead of 0, 1, it's 1, 0. Instead of 1, 1/3, it's 1/3 and 1. Instead of 2 and 1/9, it's 1/9 and 2. And 1/27 and 3. So now we truly have our x and y values of the logarithmic function up here. Y equals log base 1/3 of x. So the blue coordinates are the actual coordinates of the logarithmic function. So at this point, we don't even need these guys anymore, right? I just used them to find the coordinates of my actual logarithmic function, okay? Now let's graph this guy. Let me go to the graph and graph the blue coordinates 1, 0, and then the next coordinate 1/3, or actually let me go with the nicer ones, 3 and negative 1, and then 9 and negative 2. And now let's go for the more fun ones, the 1/3 and 1. So let me zoom into the origin here. If I go 1/3 of the way out, that's not even halfway, it's about right there. And if I go to 1, it's going to be right there. Not really halfway, but 1/3 of the way out on the x, 1 on the y. And then the next coordinate is 1/9 and 2. So 1/9 is even closer to the y-axis, right? So 1/9 and 2, 1/9 is super close. Wait a minute, I messed up. I lost my place. So we already get the idea that 1/9 and 2 is right there, even closer to the y-axis, even closer. So you're going to draw it like if it were actually on it. And if we don't have an h or k shift, and that's it, we're done, right? All you got to do is graph it. Okay? The domain. X, is x equal all real numbers? Does the graph go to this side forever and to that side forever? No, it infinitely approaches this, but it's all on that side of it. So that would be x is what? Greater than 0, that's right. Now your range, that's your y values. Does it go up and down forever? Yes, it does, so that would be all real numbers. Okay, now I don't have time to do the last one, but let me show you how easy the last one, or number 7 is, because it's directly related. All you got to do is identify h and k. Your h value is 2, your k value is 3. 2 positive, that means 2 to the right in the positive direction. 3 positive, that'd be positive 3 units up in the positive direction. Now you already know that the logarithmic function you want to find is log base 1/3 of x. And ladies and gentlemen, you already have those coordinates up here from this one. So you're just going to take those blue coordinates, rewrite them down here, and graph them, and then after that do a h and k shift to get your final answer. So I hope this helps. This will be popping out on the test this Friday.